A small steel ball is dropped into a cylinder which contains glycerin. So it looks like this. Okay, this is the ball. Now we need to find the velocity time graph of this ball. Now let's figure out the free body diagram of the ball. Let's consider the mass of the ball is m. Gravitational force will act, and as it travels inside the glycerin is going to exert a force, resistive force, which is going to oppose the motion, and that will act opposite to the gravity direction. And generally, this resistive force is due to viscosity, and if you see, it is going to depends on the velocity, viscous force. So it is going to depends on the speed of the ball. As the speed increases, the resistive force will also increase. At a particular speed, the resistive force is going to be equal to mg, the gravitational force. So the net force on the object is going to become zero, and after that, the ball is going to move with a constant velocity, which is known as terminal velocity. So that's the idea behind this. Also, we can solve this problem based on um, differential equation as well. As we know that this resistive force is directly proportional to velocity, we can just write a equation and then solve it. But let's not do it that way. With the idea of terminal velocity, we'll just try to figure out which option is the best one. So you can look at the third option. Here you see the velocity is linearly increasing. So this is possible only if there is a constant forward acceleration. But in this case, we know that it's not possible, right? Because the as the velocity increases, the resistive force will also increase, which doesn't uh, give constant acceleration. So the third one is not correct. And look at the fourth one. Initially, the velocity is non-zero, but in the question they have mentioned the ball is dropped. Dropped means initial velocity should be zero. So the fourth one is also not correct. And the first one, you can see that initially the velocity is increasing, then it is suddenly started decreasing. But this is also not possible because, as we discussed, it has to attain terminal velocity. So here, once it attains terminal velocity, it will just keep on going that particular value. So here, like it is decreasing, which will not happen. So this is also not possible. Only thing which is possible is second one. So if you extend this, it will just go in this way, which is the terminal velocity.